Hi, my name is Riccardo. I am a neuroscientist and I develop novel therapies to treat stroke patients. Stroke is indeed a medical emergency often leading to severe disability, with cognitive deficits occurring in more than half of stroke survivors. Amongst these, one is defined as unilateral spatial neglect, or more simply, neglect. People affected from neglect cannot perceive one side of the world, in the absence of any visual loss. Somehow, half of the information coming from what the eyes detect is lost when processed in the damaged brain. For example, many people who survive a stroke in the right hemisphere of the brain will stop perceiving anything to their left, as if they became half-blinded. Traditional treatments for neglect are still ineffective, leading from null to small improvements in patients' symptoms and quality of life. However, research has shown that this bizarre syndrome may be caused from a deficit in attention, which normally allows the brain to correctly process what the eyes detect. Several brain regions are actually relevant for getting attention, by interacting with the portion of the brain deputed to process visual information, the visual cortex. Could it be that, following a damage in these important brain areas, their communication with the visual cortex is disrupted, leading to neglect? Following this hypothesis, I've been exploring a novel brain training technique to enhance visual cortex functionality, which is called neurofeedback. Neurofeedback aims to teach people to control specific neural metrics by providing a sensorial feedback based on their brain activity, using a so-called brain-computer interface. In brief, the idea is to teach people to control their brain. My goal is to test if this training works and to then translate it in a therapy for neglect. In my PhD study, I trained participants to control their visual cortex activity with neurofeedback. During multiple sessions, they lied inside a big scanner which records brain activity levels. Using a brain-computer interface, their brain activity was then used to decide speed and direction of two wheels shown to the participants via monitor. Using this ongoing feedback, participants learn to control their brain to make the wheels spin faster and in the correct direction. Thanks to neurofeedback, my participants improved their ability in perceiving visual elements. Now, in order to create an easily implementable therapy for neglect, the next step is to test neurofeedback with a new brain-computer interface, which can train patients to control their brain using virtual reality. All of this into a single wearable device, like a headset. Using this tool for therapies at home or in the hospital, I hope to finally help people affected from neglect by improving their symptoms and life quality.